Okay, I want to talk about finding angles when you're dealing with vectors and vector components. Now, if you don't remember SOHCAHTOA rules, you probably learned them in math. I wrote them out here. So, sine of your angles opposite over hypotenuse. Cosine your angles adjacent over hypotenuse. And TOA, tangent is opposite over, whoops, adjacent. So even physics teachers make mistakes sometimes. And let's look at it with respect to a particular triangle. Now, if you look at this, this looks like a triangle. It's not just a triangle, though. It's actually vectors and vector components. So look at the arrows here. If you see there's one arrow that goes to the right, one arrow that goes up, this would represent an addition. So 5 newtons here that goes up to the top would actually be your resultant. And that would be the result of adding together a 3 Newton vector that goes east and a 4 Newton vector that goes north. You get a result as a 5 Newton vector. This is your classic 3, 4, 5 triangle. So let's now see if we can figure out the angles in this triangle here. So let's start with this one right there, theta. Now, if you know SOHCAHTOA rules, you can say, hey, I know that tangent of theta is opposite over adjacent. So the opposite side is 4 newtons, adjacent side is 3 newtons. So the tangent of theta should be 4 divided by 3. You can cross out the newtons. So that means if you want to solve for theta, theta is actually inverse tangent of 4/3. And if you look on your calculator, you should get a button that has an inverse tangent function on it, or second function tangent. You could also say, hey, I don't want to use tangent because I know the result on another side. You might have triangles where you don't know all of the sides to them. So you could, for example, say instead the sine of theta. Sine of theta is opposite over hypotenuse. So sine of theta is 4 newtons. Opposite side divided by your hypotenuse, 5 newtons. So theta would then be the inverse sine of 4/5. You can apply the same logic to using cosine as well. If cosine is 3/5, then theta should be the inverse cosine of 3/5. If you put these into the calculator, and I suggest that you do, just to make sure, you should get the same result for all of these. Cosine, sine, and tangent. Make sure that you are in degrees mode and not radians, and you will get an angle measure for this. You want to repeat it for this angle up here. I'm just going to call this phi. You can do that as well. Just practice up on that because it's something that you're going to need to do at times. Thank you very much.